Alright, ladies and gentlemen, welcome back to another fun-filled, action-packed, non-flipped Algebra 2 classroom video with me, Coach Goo. Today, we're going to be doing only half of this. We'll do the other half on Thursday. But this is, oh, it's frozen, you're right, wow. Very perceptive of you. Alright, so this is going to be adding, subtracting, and multiplying radical expressions. So, first thing that we want to know is this vocabulary term, like radicals. Okay, so like radicals are radical expressions that have the same index and the same radicand. Now, why is that important? Because if we have like radicals, underline, then we can add or subtract the radical terms. I'm going to show you a little general equation here. Let's say you have a to the nth root of x plus or minus, doesn't really matter what the sign is, plus or minus b times the nth root of x. What? To the nth. That's an n. It's an n. So if you look at this, what is the only difference between these two terms? The a and the b, right. It has the exact same index. It has the exact same radicand. That's the term that's inside the radical. Then we can simply just combine a and b by adding or subtracting. A plus or minus b, depending on what it was, times the nth root of x. All right, so these general formulas or equations always look a little bit complicated, but once we do some examples, you'll see that really it's not that complicated. So remember the rule. If we have like radicals, that means same index, same radicand, we can add or subtract the terms. So look at example number 1. It says 5 square roots of 6 plus the square root of 6. Now first tell me, is the index the same on those two terms? Yes. Is the radicand the same on those two terms? Yes, it's a 6. So that means we can just add the numbers together. We have 5 square roots of 6 plus, what's this invisible number right there? Not 0, or it wouldn't even be there. 1, right. So it's 5 plus 1 square root of 6, which makes 6 square roots of 6. Just like that. Wow. That's it. So look at number 2 then. What do you think the answer to number 2 would be? Close. Negative 2 square roots of x. Right. It's 3 minus 5.
So the square root stays the same?
Yes, exactly. All right, what about the third one? Wait, hang on a second. What did you say, 5? That is correct, because the same index, same radicand, so we can just subtract the numbers, 5 cube roots of x squared. What about number 4? Not possible. Why not? Right, different radicands, the x and the y. Very good. Radicand. Radicand. But this one's more like a radicant. Okay, anyways. Okay. All right, next. Okay. All right. All right. Next part. Okay, so that was pretty easy, right? But sometimes, guys, when you look at it right off the bat, you think that I can't combine them because the radicands are different. But when you simplify them, when you simplify the radical terms, you'll see that, wait a second, I can't judge a book by its cover because I can actually combine these terms. Wow. So look at this expression right here. Square root of 12 plus square root of 75 minus square root of 3. At first glance, when you first take a look at that, can you add or subtract those? Just looking at it, based on the rules that we just did?
No.
No, why? different radicands, that's why, right? Because there's a 12, there's a 75, there's a 3. Remember, you can't combine like that, right? But what happens when we simplify these radical terms? So let's take the 12 and see what comes outside of the radical, what stays on the inside. So for the 12, what can I divide that by?
2, 3.
Let's go with 2 because I heard that first. 2, 6. What can I divide 6 by?
2.
Gives me 3, and I can divide that by 3, right? So I'm circling pairs, right, because my index is 2. So here's one pair of 2. So what does the square root of 12 simplify to? 2? Square root of? 3, right. Now let's do the same thing with 75. What can I divide 75 by? Bless you. By what? 3 gives me 25. What can I divide 25 by? 5, which gives me 5. What can I divide 5 by? So 1, so I see my pair right there, my pair of 5s. So what does the square root of 75 simplify to? Right. And remember, I still have this minus square root of 3 at the end, right? So now look, after simplifying the radical terms, now they all have the same radicand, which means that I can combine the terms. So what would my final answer be? 6 square root of 3, that's right, because we got the 2 plus the 5, that's 7, minus the 1 square root of 3 at the end, which is 6 square root of 3. Boom, there it is. Okay, so let's do a couple more examples like this, 5, 6, and 7. Okay, if you want more paper, then ask for it, because I'm going to do this on a separate piece of paper, just to show you step by step what's going on right here. Wait a second, is it recording? Yes, it is. Okay, so number 5, we have 6 square roots of 18x plus 3 square root of 50x. So right off the bat, looking at it, you might think, okay, I can't combine them because they have different radicands, but let's simplify the radical terms and see what we get. So with 18, what would divide into 18? 3 gives me 6. 3, 2, and then
1.
2.
Oh.
All right, and how big are my groups? How big should my groups be? 2, because the index is 2. That's right. So here's my pair right there. And so what does square root of 18 simplify to? 3 square roots of 2, right. But what did I also have there at the beginning? X on the inside, and then what'd you say? But we were multiplying. So 6 times 3 would be? So 18 square roots of 2x is the first term simplified. Now let's do the 3 square roots of 50x. So 50, what can I divide that by? 5 gives me 10. What can I divide 10 by? 5 again, and then 2. 2. So my pair is right there. It's the pair of 5s. And so what does square root of 50 simplify to? 5 square roots of 2. And what do I have left over from the beginning? X on the inside and 3 times 5. What is 3 times 5? So now I end up with 18 square roots of 2x plus 15 square roots of 2x, which can be simplified to? Close? Close? 30? Close? 33 square roots of 2x. Okay. All right. So that was example 5. Now let's go on to example 6. This one's a little different because we're dealing with cube roots. We got the cube root of 54 plus the cube root of 16 plus the cube root of 32. All right, this is going to be an interesting example right here. So let's see how we can simplify all of these radicals. 54 can be divided by 2. Gives me 27, which I can divide by. Gives me 9. 3 gives me 3. There we go. So how big should my groups be on this problem? 3. Why? Because the index is 3. So there we go. So what does the cube root of 54 simplify to? 3 square root? Cube root of 2. Good. Now let's do the plus the 16. So 16, what do I divide that by? 2. Gives me 8. 2 gives me 4. Gives me 2. There we go. So I can circle a triple of 2's. And so what does the cube root of 16 simplify to? 2 cube roots of 2. All right, lastly, let's do 32. 32. What does 32 divide by? 2 gives me 16, and then 8, 4, 2. All right, so I can see one group of triples right here. And so what does the cube root of 32 simplify to? 2 cube roots of 4, that's right. Why is it of 4? Because these 2 times 2 is 4, that's right. All right, so now take a look at this. We have 3 cube roots of 2 plus 2 cube roots of 2 plus 2 cube roots of 4. What would this simplify to? These 2 leftover 2's right here? You multiply them, and that's what's left on the inside. 7 cube roots of 2? How is that? What? 5 cube roots of 2 plus 2 cube roots of 4. Right, remember you can only combine when they have the same index and the same radicand. So you're just simplifying as much as possible. And that would be at 5 cube roots of 2 plus 2 cube roots of 4. All right, one last example of this. Is going to be the cube root of 24 plus the cube root of 81. So let's see how we can simplify these radicals. 24 can be divided by 2 gives me 12. 2 gives me 6. 2 gives me 3. 3, and there it is. How big are my groups here? 3, because the index is 3. So there's one triple right there, which means the cube root of 24 simplifies to? There we go. 2 cube roots of 3. Now for the 81. What can I divide 81 by? Prime numbers. 3. 27? 9? 3? 3. And so I have one triple of 3's, which means that my cube root of 81 simplifies to? That's right, 3 cube roots of 3. And so what would this expression simplify to? 5 cube roots of 3. Very good. And that was example number 7. Nice. All right, so let's move on to the next section, which is multiplying binomial radical expressions. So look at this. We are now multiplying binomial radical expressions. So the concept here is nothing new. This is exactly what we've done before. We're going to multiply them by distributing or foiling, right? You just have to pay attention to the terms and how you actually multiply the numbers together. So look at this example right here. 3 minus the square root of x times 5 plus the square root of x. All I have to do is FOIL, distribute, right? So 3 times 5 is, what should I multiply next? 3 times the square root of x. What is 3 times the square root of x? Right, 3 square roots of x. We can't combine them because 3 is not inside the radical. Okay, what should I multiply next? Negative square root of x times 5, which gives me? Very good. Negative 5 square roots of x. And lastly, what do I multiply? Which is negative x. That's right. Remember, when you multiply 2 square roots that are the exact same, like square root of 10 times square root of 10, that's just 10. Square root of x times square root of x is just x, right? So it's just minus x. So I need to simplify this expression. So when I simplify and combine like terms, what's my final answer here? 15 minus 2 square roots of x minus x. Boom. Right, so the concept is the exact same. We distribute to multiply, or in this case, FOIL. And then we combine our like terms. So let's look at some examples down here. All right, number 8. What should I multiply together? Can you tell me? 3 times 4, which gives me? Okay, what should I multiply next? Right, which is? Right, what should I multiply next? What? What did you say? Right, that is 4 square roots of 5, so plus 4 square roots of 5. And lastly, what do I multiply? Which is what? That is right, it's minus square roots of 10. Remember, you can multiply inside the radical as long as they have the same index. And so there we go. We have 12 minus 3 square roots of 2 plus 4 square roots of 5 minus square root of 10. Can I combine any of these terms? No, so this is the answer. Number 9. How should I rewrite number 9? Yeah, double it. So 8 minus square root of 6 times 8 minus square root of 6. All right, what should I multiply now? Which is? What do I multiply next? Right, negative 8 square roots of 6. And then what should I multiply next? Which is? Right, don't forget the sign that's in front of this negative, that's in front of the square root of 6, right? And lastly? Plus 6 is negative times negative, so it's a plus, right? Square root of 6 times square root of 6 is just 6. All right, so if I simplify this, what would I get? 70, that's right. Because we have 64, then there's a plus 6 at the end. And then? That is correct. 70 minus 16 square roots of 6. Very good. Nice. Okay. Number 10. How would we multiply here? Let's see if we can get this one correct then. 2 times 1, which is 2. Next. That's right, it's 8 square roots of 7y. Because it's 2 times the 4 and then square root of 7y. Well, we can just multiply the 2 by the 4 that's in front and then keep the radical attached. It's multiplication. So, all right, what is next? Right, plus square root of 7y. And lastly, this is the hardest one. What is that? What is square root of 7y times 4 square roots of 7y? Close. So it is 4 times, what is square root of 7y times square root of 7y? So like this, 4 times 7y. All right, let's combine the like terms here. We have 2 plus 9 square root of 7y plus, which is 28y, that's right.
Where did it come from? Where did the 9 come from?
Because 8 plus this 1 right here. Okay, so now, what did you say? Where did I get the 4 times 7y? Because look, this is square root of 7y times 4 square roots of 7y, right? Like this. You see this? So you multiply the numbers that are in front. There's no number here, right? Which is a 1, right? So 4 times 1 is 4. Now what is square root of 7y times square root of 7y? That's just 7y, right? So you just multiply it times 7y. And that's where this last term comes from. Got it? Okay. All right, the last one then, number 11. How should I rewrite this? Double it, so get that out of there. Square root of 13 plus 6. All right, what should I be multiplying? Which is? 13, very good. What's next? Which is? Right, what's next? Which gives me? And lastly? Plus 36, right. And if I simplify this, what's my answer going to be? 40? 49. Wow. Woo, okay. 49? That is correct. 49 plus 12 square roots of 13. And that covers just basic adding, subtracting, and multiplying these radical expressions. We're going to stop there. We're going to finish the rest on Thursday when I see you again. But until then, guys, I'll see you in the next one. Peace!